Good afternoon, Jan. How do you do?
Michael, good morning. How are you?
very good indeed.
Here we
Oh,
have good
goodness.
news.
Yeah, yeah, exciting stuff to show. Yeah, I've been trying all morning to get it to transition over to my Windows machine. My databases aren't quite in the right configuration for that, so then I started setting up the Mac so that I could stream from the Mac and share it with you. So I think I've got that working. But yeah, some really good stuff on the new query language. So
Okay,
I'm excited to show this off.
that's
So
great.
yeah, and will you have something to show as well?
Well, the load method is finally working.
Awesome.
But let's start with the specification language.
All right. Okay.
That
So
looks
so the first thing I'm going to do is I'm going to do the old screen share thing. We're running, and let's take a look at specification.txt. What we have right now, let me go ahead and get down to just this. Yeah, what we saw before is that you could write a pipeline with a fact as a given, and then you can label facts within the graph and show how they are related back to the given. So this is going to show, given an improving you semester, show me all of the catalogs in that semester. And so so you can see now I've switched from the visits model to now the improving you model. So this is going against a copy of the production data, and so it's actually querying through 10 years worth of, or not 10 years, 5 years. Goodness, I've been with improving 10 years, but only running improving you for 5 years.
mm,
So 5 years worth of data, and so we can see all of the catalogs within a given semester. So what it's doing behind the scenes, you can see right here, is it is using the improving you semester that is fall 2021.
yeah.
So that's the semester in this company, improving, which is from this user, which is the public key that I generated when I first set up the company.
What?
And so now plugging that in, running that query, these are all the catalogs. So a catalog is a semester for a particular office. So you'll see that there's a tuple coming back for each improving office that had a catalog for that semester. And so we've got the bookmark coming back, and that's the monotonically increasing fact ID.
Yeah.
So now, what didn't work last time was then to go to the next level. So let's take a look at all of the courses. So I'm just gonna copy this to get me started. So we're looking for the courses. So we run that. Yep, that is the correct query. So now each one of the facts or each one of the tuples that we're getting back has two facts. So it's got the catalog and the course. So both of these being labeled facts. And now the bookmark has two fact IDs, and these are in they should be okay. They aren't right now, but they should be in decreasing order. So the very first fact ID should be the most recent fact, and then the second most recent fact in this tuple. So the
Why is that?
yeah, the reason for that is that you want to make sure that when you start at this bookmark, that the only things that you're excluding, the only things that are earlier than this bookmark, are things that truly happened earlier in time on this particular node that you're talking to. So because you're going to filter those out. So if you start with an earlier fact ID, then that means that yeah, actually that's going to cause the opposite problem. That's going to cause you to have to refetch facts that happen later in time. So basically the idea is that you've got a directed acyclic graph. This draws a path through that graph, and in fact I do have the graph right over here. We can actually take a look at that and walk through that. So here's the directed acyclic graph that we're looking through, and so we're starting at a catalog, and we're looking for all the courses. So given the catalog, and then we labeled. Given the semester, that's where we're starting. We labeled catalog. We labeled courses. So with those two labels in the graph, we're looking for all of the shapes, all of the tuples of catalog course that satisfy that particular shape, going back to that semester. And so if you were to just take a snapshot of a database and look for all of those tuples, you would see facts that have occurred at different points in time. And what you want to do is ensure that the bookmark clearly delineates the past from the future. So if any new tuples come in that match that shape, you want to make sure that they are strictly greater than the bookmark. And so
that bookmark, was that a number that increases with every fact? So for example, when you define company, it will get bookmark 1. Then you define a first semester, it will be bookmark number 2. Then you might define a catalog, will be bookmark 3. Then you define, for example, a second semester, that will be bookmark 4.
Yes. So even if they're completely different types, the bookmarks increase and are not shared. So yeah, as opposed to if you've got a separate a separate table per type, and you've got a separate incrementing ID for each one.
Yeah, and the bookmark is attributed at the moment that a fact is received by a certain server. So they are different for every server.
That is correct. Yes. Yeah, that's a very important point. There is that these IDs are only good for that particular server. So if the client is storing a bookmark, it has to know that that bookmark is only good for that server. If it ever talks to a different server, that bookmark is no good. It has to start over. Yep. So so we've got this history of catalog course tuples that have come into being. So in this case, since we know that course comes after catalog, because we have that arrow, we know that within those tuples, the second number is always going to be bigger. But if we didn't know that in general, then things could happen in either order. So for example, if we're looking through all the courses and we want the title and the instructor. So now we've got a shape that includes labels at title and instructor. And so we need to know when a new tuple arrives, when a new consistent set of facts has arrived. And so if we order by if we just pick one of those two arbitrarily, so always order by title, then if a new title comes in, that will jump the bookmark forward to a new range of numbers. But if there was a new instructor that was somehow related to the old title, then then that would be completely missed. So by ordering by the most recent fact in that tuple, we're ensuring that every time a new tuple is added that matches that specification, that that tuple is going to be greater than the bookmark, and it's also not going to skip over anything else that might intervene.
Yeah.
So yeah, that's still not a perfect description of the issue. The issue really truly arises when you've got a zigzag. So we can kind of see here's a zigzag that includes the user. So if we have if we're looking at the all of the users, yeah, there would actually be one more, like if you've got username, which is not shown on this this graph, but is part of the model. So you've got username coming back down from user. So you're looking at all of the course registrations, and you're going to zigzag back up to user and down to username. And so now you've got course registration and username that have no arrow between them, and so they could occur in either order. So a user could change their name after they've registered for a course, or they could register for a course after they change their name. So that's a more realistic example. So if you're getting all of that information, you've got tuples where registration is labeled, username is labeled, and you don't know which one is going to be greater than the other. But yet you want to make sure that if somebody registers, you get their username, and if somebody changes their name and they've already registered for the course, you get the new username. And so that's why we're ordering by the most recent of those facts that appear in the tuple. That's that is a very important component of all this. All right, so let's go back to this guy right here. Okay, so we've got from the catalog, we're going to get all of the courses. So now this is where it gets exciting. So first of all, it was just a bug that prevented that from working last time, but now that bug is fixed. So then I want to say I only want the courses that have not been deleted. So where not exists, and then I define a new set of tuples. So I'm going to have a delete. A delete that is of type improving you dot course dot delete, or it might be deletion. Let me check here.
Delete, I think.
Yep, you're correct. It is delete. And then that is related to the course. So delete course is an improving you course, where that is equal to the course here. So if that delete does not exist, then we're interested in that course. But if the delete does exist, then we're not interested in that course. So let's see if I got that right. So we run that. Lots of courses. Okay, so wow, that's a lot of a lot of data coming back. One other thing that is currently not working is the limit.
You would like to have some kind of paging mechanism?
Yes, yeah, absolutely. Okay. Yeah, so so what you're seeing here, yeah, so this is a good example of a now here's a tuple that contains 3 facts. So we've got the catalog, we've got the course, and we've got the delete fact.
Yeah.
So if you think about what this specification means, this specification is asking for just the courses in this particular in a catalog of this semester that have not been deleted. And so this particular course would not match the specification. So, so if you were running this in order to update the user interface, then you wouldn't show this course on the user interface. So why is it being returned from the specification? And so the reason for that is that this is not giving you the answer, it's giving you the evidence. So this is giving you all of the facts that you need in order to determine what to show on the user interface. The reason for that is that if you've got this course cached already, so you've been running this application, you've logged in, the course is listed, and then you log back in, the client's going to ask for new information. So if this deletion was not returned, then that course would still be there. It would still show up on your user interface. So we have to give the client all of the evidence that it needs in order for the client to make the determination. And so that means that that all of the course deletions are evidence. And so the entire tuple, including the course, or the catalog, the course, these are the labels at the top level, and then going into the existential query, delete, add that label, and now you've got a tuple that has those three elements in it. So, but that's not the only tuple that you get, because if that were the only tuple you get, you would only get the deleted courses, because you get a complete tuple. Mm-hmm. So if there's no deletion, you still want to have that course. I mean, that's what the specification is asking for. So this is actually giving you back two feeds. So the deletion should be the first feed. Yeah, here we go. This is where the second feed starts. So this feed gives you back course and catalog, not delete. And so these tuples just have two facts. And the bookmark is just 2 segments long. So now this bookmark is only good for this feed. That bookmark there is only good for the deletion feed. And so ordering by most recent should actually be the ID of the deletion. So we'll just kind of march forward through time. Every time something is a course is deleted, a new tuple will show up in that feed, and the bookmark will progress. And we'll pull that down, apply it to our local cache, and then run the query inversion, update the user interface accordingly. So that's how these existential, the negative existential conditions get applied. They create additional feeds. The easier one to do, but far less common, is to do the positive existential condition. And that was easier because you don't need to create an additional feed, because you're only interested in courses where delete does exist. So maybe this is a specification you would use for the recycle bin. So this is the list of deleted courses. You can go there and say, oh no, restore that one. So now I'm only interested in the courses where delete does exist. And so if I go down to where that starts, that should be a much smaller, yeah, there we go. There's a much smaller result set. So now it's just got the feed of catalog course delete. So it goes right into the existential condition and just adds that to the tuple. So these are the courses that were deleted in fall of 2021. And it should be oh, that's actually a larger number than I was expecting. I didn't think that we deleted courses that often, but yeah, there we go. We've got, yeah, it looked like about 10 different course deletions. So just that one feed with just that one bookmark. Okay, so that is existential conditions, both positive and negative. then, so let's go ahead and make that negative existential condition. Now let's take a look at the registrations for that course. So this right here is the role name, and this right here is the label name. So I've labeled it as registration, but the role inside of the deletion fact is actually course registration.
Yeah.
Okay. So make sure that that was correct. Yeah, that is correct. So now it is running two different existential conditions. So as it's coming through the specification, it's looking at each one of these labels in turn. So looking at the catalog, looking at the course, and then applying that existential condition. So now it pops out a feed of catalog course delete. So we already talked about that one, and then it continues, and so now it's saying, okay, catalog course registration. There's another existential condition, so it pops out another feed of catalog course registration delete. And yeah, so I think one thing that I want to do is to ensure that I've got different labels, even if you've got different existential conditions. That way you can unambiguously take a look at each of the different feeds. Although maybe that's not, because yeah, one of these feeds is catalog course registration delete. Yeah, that's not gonna cause a problem. So so yeah, then it continues from there, and it says, okay, now let's look for just the tuples that truly are courses that have not been deleted and registrations that have not been deleted, and then you'll get your catalog course registration feed. And so that's the last one that we're seeing here is catalog course registration, and yeah, there's going to be enough of those that the other feeds have scrolled off the screen. So these are the registrations that have not yet been deleted. So here the important thing is that it only continues to match the rest of the tuples if this existential condition is true. So that means that if a course is deleted, you are no longer going to get all the registrations for that course, but you're still going to get enough evidence to know what to display for this particular specification. And that's because you're going to receive on a different feed the deletion of the course. And so according to this specification, you're not going to display those registrations. So you don't care.
It's a little bit like tombstones.
Yeah. Yeah, exactly. Yeah, so that was something that I was kind of scratching my head over a little while back. It's like, so okay, let's talk about the contact, like the CRM system. So you've got you've got a customer in your CRM system, and they've got a name and a phone number and email address. And so then if somebody comes in and deletes a customer, but then somebody else, not knowing that the customer has been deleted, updates their phone number and their name, when you pull that information, I want you to just get the deletion. I don't want you to get all these other changes that have happened. So I want the tombstone to get to you, but I don't want any of the other successors to get to you. And that's even more important if you are now starting this application fresh. You've got an empty client database, and you're pulling down all this information, and so now, over time, people have been deleting customers all over the place. So what I want you to get is all of the tombstones of these are all the deleted customers, and then nothing else about them. And you don't need that information because you've already specified I'm not going to display that information. So by applying the existential condition before we continue, we're getting that behavior. So this was really cool to see this working, but then I wasn't quite satisfied. There was one other capability that that I really wanted to make sure that I got, and that is to have multiple starting points. So you can also have not just the semester, but also the user who's logged in. And so now this really allows you to create a specification that truly represents your application. So the application starts up, you log in, and now it knows, oh, okay, this is the Jinaga user that that is interested in this data. You navigate through and you say, okay, I'm going to open up the semester. Oh, okay, this is the semester that you're interested in. There might be other contextual facts that that you bring in, and so each time you select one of those contextual facts, you kind of navigate to a certain part of the application. It just adds that to the givens. So it says, okay, you are in this particular area, so let me go ahead and fetch the data to satisfy that area. So we can accept multiple givens. If we save this right now, it will say that the graph is not connected. So I've got a semester over here, I've got a user over here, and if I take a look at the graph, so we've got starting at this semester, starting at this user. I'm interested in all of the course registrations, but so I've got some parts of the specification that connect semester to registration, but nothing is connecting back to the user. So we need to fix that. So we say, I'm only interested in the registrations where registration user being a Jinaga user is equal to the user. So that satisfies the that connects the graph. Ah, wait a minute, can't generate the SQL. Oh, interesting. Role user. Oh, okay. Yeah, yep. User is not a defined role in improving your course registration. It's called student. There we go. Ah, there we are. So now we have just the registrations for this particular user. So now this is going to be a much shorter list of registrations. These are the two courses that I registered for in fall of 2012. And actually, I think one of these two I taught. So, so we've got the catalog course registration that is now constrained to just those users. So it brings that condition in. The catalog course registration delete. So so now see the deletion condition takes into account the other two conditions. So now we're only interested in the registrations that have been deleted where those registrations are from me. So I didn't unregister from any courses during that semester, so that feed comes back empty. And then this going back to the course deletions that occurred within that semester. And you can see that we've got all of the course deletions because we've only come through the specification this far, and so we're not concerned about whether I have registered for those courses or not. So the order in which you put these conditions is important to what feeds you get back and how those feeds are constrained. But
that is nice.
Yeah, that was that was many nights of head scratching and like I think I got it, and then it works for a lot of scenarios, but then it fails in some scenarios, and so now I think I've got it. And this particular specification right here really exercises a lot of the a lot of the shapes that you could create. I guess the only thing that it doesn't exercise is the positive existential condition. So if we do that, then yeah, now we've got the positive existential conditions going on. So these are just so all the evidence in previous feeds followed by just the registrations that I have deleted myself, which is of course an empty feed. So that is that makes me really happy.
So you've been using this full new specification on client and on server side, or
not quite yet. So so yeah, I really just got this this working night before last. Yeah, yeah, and it's just working on the server side. So the next steps are the so I can run this in unit tests, integration tests, and this this interactive test right here just for demonstration purposes. But the next step is to then provide an endpoint so that you can send the specification to the server, and then it'll run the query for you. And then it needs to be plumbed into the clients. So I could then transition to the Jinaga.JS client and start to produce this specification. But instead, what I'm planning on doing is transitioning to the Jinaga.net client and having it take the link expression and the specification that we build that way, and then start to build these. And then Jinaga.net will call that new endpoint on Jinaga.js and make these queries.
Okay.
So
That's gonna be nice.
Yeah. Yeah. Oh, yeah. And there is a bit more to do on the specification language, and that is to add the projections. So now that you have all of these catalog course registrations, now you have all those, you should be able to then say, hey, what I'm interested in are the titles, and so that's going to be another tuple, which is the course title is an improving you course title, and where that is related to the course, which is defined in this tuple here. And so this is projections are really just a way to do a left join. So you've got all these tuples. You're interested in them, whether they have titles or not. But then, once you've got them, for each one there, you're also interested in the titles. So, so continue the tuple from there. So now you should get a feed of catalog course registration title, course title actually. And so you'll get a feed of those tuples, and that will tell you all of the course titles for the courses that match this particular specification. So the titles of the courses that this particular user has registered for in this particular semester. And then continue down. Also do the instructors. Etc. etc. So yeah, right now this should parse, but it should not. Oh, okay. It actually does produce SQL. This SQL doesn't take the projections into account, so it's actually not doing. You can see we still have catalog course registration. So that's the next feature to complete on the specification execution, but I think that this one is going to be pretty simple because it's just now recursively doing the same thing that it did before, but now assume that this part of the tuple is already filled in, and then continue building from there.
It's not so easy.
Yeah, but now so this, even though it's not too bad for a human to write this, and in fact you can see Copilot is having a really fun time with this. It's figuring out how to write this specification language, getting it right most of the time. So so even though it's human readable, the intent here is that this is going to be machine generated. If we take a look at the specification data type in Jinaga.net, I think we will find that Jinaga.net specification data structure already looks a lot like this. So there might just be some tweaks in order to make it exactly match this. So so then the idea is that we should be able to take this query execution, translate it into .NET, and now we'll be able to use the same thing in order to query against the local client cache. Furthermore, we will be able to take the entire running application and compose this data structure from the way that the application is written. So take all of the different link statements that appear throughout the application, and so a link query will generate a view model or a view depending on what library you're using, and then that view model will then have its own link statements that that continue down. And so so when, for example, we've got here's the list of all of the the courses for which you've registered, and then for each one, let's generate a view model that shows the title and the instructor for that particular course. And so you've got those specifications within specifications, and they all get composed. And so the application, after you've composed your specifications, should be able to take that whole data model, that whole specification model, send it all to the server, and say, this is the shape of my application. This is what my application looks like. And then the server then sets up these feeds, and it starts feeding the application facts as they arrive.
Yeah.
So so it's kind of like the GraphQL idea of the client gets to determine the shape of the data that they're interested in. But here, the shape of the data that you're interested in generates a bunch of feeds, and then you can set a bookmark and you can follow those feeds forward through time. So it's not just run the query and get me back the results. Thank you. When I need to update the user interface, I'll run the query again. Nope, it's like, let's run this query, let's keep those feeds going, and then come back later. Hey, anything changed since this bookmark these bookmarks on these particular feeds, and you get to adjust those changes. So this is basically the shape of your application, and then the client is just binding this to view models, binding those view models to the view, showing them to the user, and it's all generated behavior.
Mm. So actually, the watch is also based on these bookmarks.
Yes, absolutely.
Okay.
Yep. Watch just does one extra thing before it gets here, and that is that it runs the query inversion. So when these facts arrive from the server, so hey, here's a brand new course registration, then the client says, oh, I don't have that particular fact in my local cache, so let me go ahead and collect all those facts that I don't know about call the server and say, load these, and then you get back a graph that has all of those facts that you don't yet know about. They land on the client, then it runs the query inverse. The query inverse says, okay, this part of the user interface is interested in this fact. And so then it updates the view model, updates the user interface. So yeah, that's the additional thing that happens with the watch.
Okay.
Yeah, and the idea is that as an application developer, you shouldn't have to think about such things as, hey, when somebody deletes a course, then I need to update this UI. Therefore, I need to add a new message to a topic. And as an application developer, I need to write the code that reads from that topic using a particular bookmark. I don't need to write an API that says, hey, give me everything that changed on this particular topic from that bookmark. You don't have to update that API as your model grows. So you just change your link queries on the client. It regenerates a brand new specification for your application, which updates the feeds that the server generates. For the feeds that you were interested in before, those bookmarks still work. Those feeds are still good. But now you've added a new feature, you're interested in a new fact, here comes a new feed. You start reading on that feed from the beginning.
Yeah.
Yeah, this is gonna be awesome.
It's going to be a lot of playing with to get through the bottom of it.
Mm-hmm.
Because at least it allows us to completely define the data model
Mm-hmm.
and not to have to worry about what is lying underneath it, what is in the database. It all gets data that is completely independent of the structure.
Mm-hmm. Yes, indeed. All right. So, yeah, maybe what I'll do is I will go back and take the recording and see if I can just kind of follow along and re-record the what I'm typing while, and then just kind of overlay that on the recording. Yeah, I think that'll work out.
You do have a recording, but not the camera from the Mac, or?
Yes, yeah.
Okay.
Yeah, so it's got all of me explaining things and all of your questions and all of that good stuff. But yeah, just not me actually typing. But I can recreate that, overlay that. We will re-release this video.
Oh, that would be good, because this is one of the fundamental explanations.
Yeah.
And Caden is not there, so he will also be interested, I think.
Yeah, I think so. Yeah, so if you're watching this video and you saw just us talking, then come back later and you'll find a better video.
Can I show you the load?
Yes, please.
Share the screen. Where is it here? Where is my Jinaga.net? Yeah, okay. Let's make it a little bit smaller. So from last time we had this, is it readable like this, Michael?
Yes, it is.
We had this load nothing from star.
Mm-hmm.
That was simple. We had this immutable list of fact references, which was empty, and we loaded, and so he returns nothing. That was working. Then we had this load from store, where last time I made the records in two ways. One way was through g.fact to save them to the database. And then I used fact.create, and the purpose was to have the graph to be able to retrieve, to load them again.
Mm-hmm.
But then we discovered that actually all of this was not necessary. We could just use the last ref here, and that last ref that came from graph.last, where we use the fact manager to serialize the last passenger name.
Mm-hmm.
Yeah, so all the rest could be commented out. So what we do, in fact, is we created a number of records in the database. We load them again, and we check whether we have indeed 6 records. 6 records. Why? Because we have the airline 1, the user 2, the passenger 3, and 3 passenger names.
Mm-hmm.
So that makes 6. So if we go and have a look, load nothing, load this one, and I just run it. And if Murphy is not watching, then it will turn green. And he's green. So this was based on the passenger, on the airline model.
Mm-hmm.
So then I made a second test. Immediately we go to the underlying implementation. I made a second test, which is load from store DBS.
Uh-huh.
So here I'm using my own model.
Nice.
Yeah. Why the second test? Because I want to be sure that my serialization, deserialization is completely independent of the model. So here I have a supplier, a client, a yard, and 4 addresses. So 7 different records.
Mm-hmm.
Should be 7. That's this one here. If I run it, it should also work. Did it run already? Apparently, yes.
Yep.
Okay.
Yeah, it was fast.
I can also exchange. I'm now using as a store the SQLite store. If I just make it like this, then I'm using the memory store.
Mm-hmm.
Just to be sure that is also working. And it should give exactly the same result, and it does work.
Excellent.
That means that you programmed well, Michael. No doubt,
Yeah.
no doubt about it. So let's go to the SQLite store. Where were we? So it is working, but it's not optimized. Yeah,
Mm-hmm.
like usual, Jan is always last minute, and so there is little time for optimization. No, I was not really last minute this time, but I was struggling with the deserialization with the SQL language also, because this with values thing, a tuple, searching for a tuple in a value, the syntax in Postgres and in SQLite is not exactly the same.
Right, yeah.
Let me silence the phones. So you in Postgres, you can just put it in a join. Here we can put it in either in a where clause, either if we have joins behind it, we have to put it as a condition in the join itself.
Interesting. Yeah.
But if I can put it in a condition, in an end, then why was it not working directly? Because I've been searching for that syntax in SQLite. It didn't work.
Yeah, I would expect you'd be able to put a where clause on that second half of the union as well. Yeah.
You mean here?
Yeah, that.
Yeah, but I'm having joins behind it, and that didn't work. Now, this one was one of the things I added this morning. Yeah, here it's afternoon, so this part I added this morning, so I didn't look too much for it. You even see I have a join with effect type here,
Yeah.
and I have a second join with effect type there. So it's even less optimal than what we discussed last time.
That makes sense because those are two different facts. You're looking for the fact type of the ancestor and the fact type of the.
But we should be caching it and then.
Okay. Oh, right. Yeah.
But okay, so this. So what is happening here in this load? If I don't have references to look for, then the result is 0.
Yep.
Otherwise, that's where we start now. We work with our connection factory. First, the references, I convert them to just an array of reference values. Yeah, these tuples with hash and type. Convert them to an array, and then just join to make it a string of all these tuples. The result, it gives me what I called a fact from DB, which is actually just a class with a hash, a data, and a type name.
Okay.
And so this query gives me an enumerable of these structures. Then these structures, I made an extension deserialized, which gives me an enumerable of facts.
Okay, yeah.
Started playing a little bit with
it. And then
it.
you just add them all to the graph.
And then I did exactly what you did in your memory store.
Yeah.
Aggregate and put them in. Yeah. No, I wanted to try this link syntax. And then, so that graph I return back as a task.
Excellent.
So if we go, that's this fact from DB structure. So we have a hash, we have the data, which are the fields, and
the predecessors are also in there.
And the type name here.
Yeah, so I'm going to have to take a look at fact graph and make sure that you can add them in any order, or if it requires a topological order, because there's no guarantee that query is going to return a topological order, but yeah, it seems likely that it would. So it should return the predecessors before the. Well, actually, you've got the union of return this fact and then return their predecessors, so it should actually be returning them in a non-topological order most of the time.
The most recent ones, perhaps first.
Yeah.
But then the ancestors, I should put an order clause in here somewhere.
Yeah.
I guess.
Yeah, possibly. Or if it's maybe maybe it could do a topological sort as it's building the graph, but yeah, each of the intermediates would not be a valid fact graph if it's not topological. Okay, yeah, we'll have to play around with that.
Because I was thinking I should compare the initial graph that I get back when I save and the one that I loaded to have a full test, but I didn't do that yet, and then I would have discovered that.
Okay, yeah.
In order to add
Yeah, I'd be interested to see how that turns out.
Another thing, what I have here. Yeah. That's my daughter calling, but she can wait.
Goodness. That's dedication.
Yeah. No, they are priorities. Now I'm doing this. Where was I? In the load. So I'm creating. Wait, no, that's in the deserialization here. I'm creating a fact here. Here. The problem is this fact.create is the only public method on the fact class, but it calculates the hash itself. It calculates the hash itself.
Right.
Is that what we want? Or do we just add another method to the fact class where we use the hash that we load from the database?
I think we want to have it calculate the hash itself and then validate that it got the same hash. Yeah. So it could happen that your database gets corrupted, and yeah, the data doesn't actually match the hash that yielded that data. So yeah, this is kind of like the interplanetary file system ideas that somebody looks up a document by its hash. When they get the document, they should be able to hash the document and verify. So yeah, this I think it makes sense for us to do the same thing here.
So go through the hash all the time again. It is a performance issue, perhaps.
It is, yeah. Yeah, so it's a question of how much do we trust our local database. Yeah. Yeah, certainly on the server. On the server, I definitely validate hashes because I certainly don't trust the information come from the client. It's like, here's a fact with this hash and all of its data. It's like, yeah, I'll check that hash myself. Thank you very much.
Let's see. After a lot of time, it should be robust. Actually, this week I got a customer of me calling me, and he had a big problem. I'm using these keys as a kind of wallet for my software. They make inspection reports of weight scales with my software, and so every time, and it also generates a unique number, or it adds a number for the numbering of the reports. So more than 20 years ago, when I started developing the software, I said, okay, 9,999 reports for an inspector. That should be, I will be retired by long. And so two days ago, I got the first customer, and I was really surprised to hear that.
Wow. Oh no. I think we know how the story continues, but
there we run out of Discord.
Yeah.
No.
Yeah, 9,999 seconds. That's it.
999. So that was amazing.
Wow.
So now I said, okay, that's why there are not too many bugs anymore in the software. It's well tested. I never thought they would use it so much. Oh, but now he's not sharing the screen anymore. Let's quickly, because we're running out of time also. Okay. So, what I did here, so the extension is just taking in an enumerable of facts from the database. I walked through them, just a JSON document, and for the fields, so the first portion here is for the fields, and the second portion is for the predecessors. So I enumerate all the objects in that field. It can be either a string, a number, or true or false. And so dependent on that, I add a field value string, a field value number, or a field value boolean
Okay.
to the immutable list of fields. With the predecessors, it's a little bit more complicated because I have my predecessor single here, or I have my predecessor multiple.
Right.
So if the kind of predecessor is just an object, then it is a single. If it is an array, then I have a multiple. So I have to get the hash, the type. Both of them can make a fact reference. And so with that name, which is the type name and the fact reference, I can add them to my predecessors list.
Yeah. Yeah, I'm actually surprised that this code doesn't already exist in the memory store. I might have cheated. I might have just I probably
I was hoping that no, because the memory
I probably
store
saved
is
these fact objects rather than turning them all the way to JSON and back again. Yeah.
Yeah, it was never here is the memory store. Where is it here? The load.
Oh yeah.
Look, that's the part that I copied, the aggregate.
Yep.
But you started from your references immutable list, which has these facts inside. So this was very compact, but I couldn't use it.
Right. Yeah. Okay. So fact by reference just stores fact objects. It's just a dictionary of reference to fact. Okay. Yeah. Not serialized. Yeah. Okay. Yeah. Thank you for that. That's
well, I had to start from JSON.
Yeah.
Now
that is probably going to get brought into the core library because that's an important feature.
I haven't checked anything in yet. I will clean it up and check it in portions. Sometimes I'm so bad in GitHub or in Git that I keep on working. I never clean up, and then at once I have to to start checking in. I'm not sure if that is the fastest or the most performant way to deserialize it. But the problem, I couldn't make a fixed class, because my predecessors, they all have a different name. Yeah. Predecessors has a prior element, okay, that one is fixed. But for example, a passenger could be a predecessor. Whatever, it's model dependent. So to get, what is it here? To get the hash, the type, the predecessor.name value. Yeah, I had to start from an object which I search for the properties. I cannot search for the names directly because the names change all the time.
Okay.
So one of the things we could do, perhaps, this JSON deserialization built in C# allows you to make extensions.
Okay, right.
For certain types. And so, for example, this predecessor single and predecessor multiple, we could make an extension for it, and that might work faster. I don't know.
Okay, yeah, because then it would be instead of deserializing to a generic DOM and then pulling it into these, it would just be calling our code, saying, okay, here's the next field, here's an array, and then here's the elements, and then we just produce the appropriate component of fact, and then by the time we're done, here's fact reference. Yeah, I think that could be an improvement.
So but we will see how it goes. I think once we have data in it, we can do some testing, and if it is too slow, we will work on improvement.
Yeah, and I think optimization should definitely start at the network, and then once that's optimized, then go to the database, and once that's optimized, then it can go to data structures like this. So yeah, I think we'll like the whole specification versus the linear pipelines. That's a huge network optimization. Once that's done, then some of the these individual round trips to the database that you're doing, turn those into set operations that would optimize the database. Also cache the fact IDs and the role IDs, so that that's going to be a huge database optimization. So yeah, I think this is after those, but yeah, certainly can be an improvement.
But so this is working now. I will clean it up a little bit and put it in GitHub then. Then you can have a look.
Awesome.
What would be the next step that I can look at?
Yeah. So the next step actually would be now running a query, but yeah, I want that to be this full specification execution rather than the linear pipeline. So that's some pretty intricate code. So
this was easy code.
Yeah.
I will give you the solution in 5 years' time.
So I think.
No. Let me have a look at it.
Yeah, I think certainly going through the pull request in Jinaga.JS and understanding that that data structure, I think comparing that with the specification data structure that's in Jinaga.net, and just seeing what the differences are. So yeah, you should be able to generate the text of a specification from a specification object in Jinaga.net. So that might be the next thing, because we'll need to go that route.
Text, the new format like you showed it today.
Yes.
Okay.
Yeah, so that's going to be how it talks to the server. There's going to be a different path that then turns that specification into SQLite, and that's going to be similar to the the huge amount of code that made that work. So yeah, in one of our upcoming calls, I will go over the way that code generates SQL, and then we can decide how we're going to split up that work. So yeah, basically porting that over to .NET and making it work with SQLite.
Okay. Great. I'm taking already 13 minutes extra of your time, Michael.
All right. Yeah,
I'm not going to be happy.
Yeah, but yeah, my team is not going to be. Yeah, I'll just stand up from the car on the way in. It won't be a problem.
Okay.
But yeah.
See you next week.
This is progress. Yeah, indeed. See you next week, and hopefully by then I'll have an edited video up for everyone to watch. So.
Yeah, that would be great, and I can study it again also.
Yeah, because there's a lot
Michael,
of
thank you.
there.
Yeah, thank you very much, and see you next week.
Thank you. See you then.
Bye-bye.
Bye.